My YouTube channel. Our given question 9 read as follow. It says an aerial view of a stretch of road is shown in the diagram below. The road can be described by the function of y is equal to x squared plus 2, comma, x is greater than or equals to 0 as the, okay, you can see in that portion. If the coordinate axis dotted lines are chosen as shown in the diagram, benefits vantage point B. We have given point B, vantage point B 0,3, and observes a car P traveling along the road. Right. So it says we should calculate the distance between Ben and the car when the car is closest. Note of this word closest. You must understand, if you see the words closest, you might think you must always, we're talking, you have to take a first derivative. If you see names like closest, things like maximum, all these words, maximum, nearest, if you see those words, nearest, minimum, largest, smallest, those things you're supposed to take the first derivative and equate it to 0, or you're supposed to take the derivative. Well, at the moment, once you see those words closest, obviously you're supposed to take some derivative somewhere, somehow. All right, so that is what we're given them. They say they want what? The distance between Ben and the car. We want this distance there. We want that distance. All right, so we have the points now. We're given the point P. Here we're supposed to have the point there, point P. So we don't know the value of x. Actually, we can just say x. We can leave it like that. But note, they said y. It's equals to that. So we can equate the point of y. We can let it to be called x squared plus 2. That's the coordinate of P. But the coordinate of P, we have it. So that will be fine. That we know that we can apply our distance formula. Now we can apply the distance formula. We know that x1, or we can say x2 is up to you, x2 minus x1 squared plus xy2 minus y1, you square this, then that is why you're supposed to apply that distance formula. All right, now we have the coordinates, so I can write this on the bottom a little bit. Okay, now the distance, we know will be the distance of PB. We'll apply the distance formula, square root x2 minus x1 squared plus y2 minus y1 squared. So this is our distance formula. We know the points there were given, our point B and point P. So we have point P there. Point P will be that x comma x squared plus 2. All right, this is our first point. Then we've given also point B. Point B is 0, 3. It's our second point. So we can find the distance. We can apply the distance formula there. All right, let us substitute. Now we have the points there. We have PP square root. Let's substitute x2. Here it's x2. I wrote 2 there. x2 will be what is 0 there. We'll have 0 minus x1. Here it's x1. It's simply x. We'll have x there. We square this plus. We have now there y. We'll have y2. Here is 3 minus y1 is whole of that. Since you have 2 terms, put the parentheses of brackets. We'll have x squared plus 2 like that plus 2, right? Do not forget to put that square again. We square that. We have this now. All right, then we have PP, the distance PP is equal to the square root. Obviously, when you simplify this, we'll have negative squared. You will simply have what? X squared. Then here, okay, try and distribute the negative. We have plus, we still have plus, brackets, we have 3. Distribute the negative, we'll have minus x squared. Distribute there, we'll have negative 2, negative 2, then all over this square. All right, this is what we have. So this we have 2, we have 3, can subtract there, we'll have 1. So the distance PP must be equals to the square root of x squared plus those 2 will simply equals to what? To 1. So we can write there, we have here, we still have a negative there. So this will be 1 minus x, we have squared, don't forget with the outside squared there. This is what we have now. All right, so that is what we have. Again, PP, we have PP, then we have now the square root x squared plus, now you see this guy, we have to square those. It's like that one is like we have 2 brackets. It's like you have x, it's like you have 2 brackets there. It's like you're multiplying 2 brackets like that. As you can see, this will result as that. So when you know, you have to distribute there, distribute and distribute and distribute, right? If you distribute there, you're supposed to know, you'll get that. You'll have obviously 1 times 1 multiplied by 1 will simply have 1, right? Then we have that. Then the fact to multiply like that, you're supposed to have that, you know, that is basics. You'll have x 2x squared plus 4 plus x raised to the power 4. There, as you are doing what you are doing there, you know, most the x raised to the power 4, just FOIL there. Still have PP square root. Now if you can check this guy here, x squared minus 2x squared, this is like, you see those 2 there, they have a sort of like a region there. As you can see, like you'll cancel, it's like you have 1 minus the 2 there, something like that. It's like as if we have something like that there. All right, or let me just pack them in the, you'll have that negative, as you can see there, but you have also x raised to the power, sorry, but also you have x raised to the power 4 there. So I can start by writing that x raised to the power 4, but I know these 2's are like terms, will have negative what? Negative x squared. We have plus 1, we still have that 1. So this is what we have then. So now here will be, there's nothing we can do here. There's nothing we can do when we reach this point. We've simplified this as far as possible, but remember, we're supposed to find we have to find the distance there. They said we shall find what? The closest. We're supposed to take the derivative. So you cannot take the, if you have a square root like this, it will be difficult for you to take the square root, because you'll have to apply a chain rule. Then the chain rule is not allowed. You cannot use chain rule, you guys. So just take, let me just swipe outside. I'll have PP. Then this and this will cancel. I'll have x raised to the power 4 minus x squared plus 1. So I can take a derivative now. Can differentiate this guy here. Can differentiate that guy. Take your first derivative then. You understand? You know, you can take p2 prime, or you can use this, it's one and the same thing, or you can use d over dx pp squared like this. It's one and the same thing, so it's up to you which one. Still it's one and the same thing, that one. So that is what we have there. It's a one and the same thing. So can differ, you know, we'll take our first derivative, dy dx pp squared. So if you are taking this, you will drop the exponent, you'll have 4, then minus the exponent, you'll have 3, drop the exponent, negative 2x minus the exponent, then this will simply equals to 0. Since this is a constant, so you have this. But remember, since it's a nearest, we're talking about the nearest. It's like the nearest and the maximum and the minimum, it's when our gradient is equals to 0. Remember, if you have the maximum there, the gradient there is equals to what? To 0. The current, so those weights, nearest, largest, we're supposed to, after we have taken the first derivative, we substitute that first derivative to 0. This derivative will equate it to what? To 0. So we can equate that to what? To 0. We'll have 4x cubed minus 2x. All right, so we have the common factor here. We can take the common factor. 2x is a common factor here. We'll be left with 2x squared minus 1. So you know what you're supposed to do. You can equate here. You can have 2x equals to 0. 2x squared minus 1 equals to 0. Let me write here on the top again. That is simple algebra. When you divide here by 2, obviously x will be 0. Then here you transpose that, you'll have x squared is equals to positive. You divide both sides here by 2. Divide both sides by 2. This and this will cancel. You'll have x squared there equals to 1 over 2. Then you have to take the square root both sides. Alright, this and this will cancel. Remember, when you take the square root both sides, you'll have plus or minus. Obviously, this is the same as 1 over square root 2. No, do you know? Remember the laws of sets. If you have a over b, like all over square root like this is the same as square root of a over square root of b. So I apply that, but the square root of 1 is simply 1. Yeah, that it is the law that we've applied then. So this is nice. We have now two values there. Its x will be what? It's either x, you have positive and minus. It's either x will be negative 1 over root 2, or x will be positive 1 over root 2. But remember now, we've given that x must be greater than what? But must be greater than 0. We're given there when they said x must be greater than what is 0. Alright, so that means we'll use this value now. They said x must be greater than 0. As you can see, greater than 0 here. X must be greater than or less than. X must be greater than or equals to 0 here. So we'll use that one. So we'll use this part of greater than. Hence we don't have something. Negative is less than 0. So we'll use this value then. 1 over root 2. So we can substitute that 1 over root 2. Alright. Substitute 1 over root 2 onto our equation. We know that which one is that? We had that p we know we have left that it was square root. We had x raised to the power 4 minus x squared plus 1. We have left it here. Remember, now we can substitute. You can substitute pp will be equal to the square root. When I will replace that with what? Remember, we have x now. We said we got that x to be 1 over root 2. So we have 1 over root 2 raised to the power 4 minus 1 over root 2 squared plus 1. So obviously pp, that is our distance you're supposed to have. Punching this, obviously these are just for you, putting that on your calculator. Supposed to get this to be 0.87 units. So this is the length that they wanted, that is the distance that they wanted. So thank you for watching, and then may you kindly subscribe if it's your first time watching my video. Become the part of the family. Subscribe, click the notification bell so that you'll be notified whenever I post the new videos.